Welcome to the interesting flow. How was the amazing Museum of the Future in Dubai built? Let's find out. The Museum of the Future is one of the most difficult construction projects ever attempted in Dubai, a city that is rapidly expanding. Residents of Dubai, where tower complexes appear out of nowhere, have mastered the art of averting their gaze. The Museum of the Future, looming over the city's elevated, driverless metro system on the edge of the financial sector, has captured everyone's eye. The museum's framework, made up of 2,400 diagonally intersecting steel pieces, was finished in November 2018. The museum will open a year from now, on October 20, 2020, when Dubai will host the World Expo. The museum's futuristic shape is a torus with an elliptical vacuum, but a huge hula hoop would be a better analogy. Lath Carlson, CEO of the Museum of the Future, compares it to an eye. To those who haven't seen it, we struggle, he acknowledges. Nothing quite evokes the shape. The museum's design was chosen by the local architectural firm Killa Design in 2015. The architect says the solid component of the structure represents today's knowledge. The emptiness depicts the unknown, the future. The building's unique profile sets it apart from the hundreds of other construction sites across the emirate. As the facade panels are installed, more of the Arabic calligraphy that will grace the 78 meters high museums outside is revealed. However, the words are recognized to be poetry penned by Dubai's ruler Sheikh Mohammed bin Rashid Al Maktoum, who is also the UAE's vice president and prime minister. The cursive inscriptions are the museum's windows. The 14 kilometers of LED lighting will produce dappled light across the column-free interior during the day and dramatic light at night. Constructing. The calligraphy plus the building's odd shape made this one of the most difficult construction undertakings ever attempted. The project's primary consultant, Bureau Happold Engineering, claims parametric design and BIM would have been impossible without them. BIM. Parametric design is an algorithmic approach that permits particular variables or parameters to be changed to change an equation's output. BIM is a collaborative three-dimensional model-based tool for building professionals. Despite its long existence, the industry has been sluggish to adopt BIM. We realized we needed everything digital since you couldn't specify everything geometrically, explains Tobias Bowley, project director for Bureau Happold's Museum of the Future. In that case, the shape would have been dumbed down and the construction would have been much more difficult. This project was made possible by technology. It required the project director and his team to quickly learn 3D modeling. Everyone had to learn BIM completely and adjust their daily routine, he explains. The first computational challenge was to fine-tune the building's theoretical shape to remove complex curvatures. These minute changes, which took a long time to complete, were imperceptible to the naked eye, but prevented future issues. Then followed the diagrid steel framework and the lightweight facade. An alternative to a steel or concrete shell was chosen for a building of this shape and complexity. Bureau Happold created its own growth algorithm to find the ideal diagrid configuration. A long procedure, but it allowed Bureau Happold to prescribe outcomes like having steel members of a single diameter and orderable from the market. The outcome was a diagrid with fewer connection points, smaller steel tube diameters, and less steel overall, saving the client, contractors, and fabricators money and time, according to Bureau Happold. Before starting construction, BAM Higgs and Hill and Eversendie Engineering performed a construction sequencing study and connection design for the structure, taking into account shifting stresses and loads throughout erection. A lot of member alterations occur due to the construction sequencing analysis, according to Bali. Because the diagrid had been optimized and modeled, none of the steel members were changed on this project, he claims. We used previous project learning and established tools to solve difficulties we knew existed, so we wouldn't have to confront them again. The steel work took 14 months after the reinforced concrete ring beam and tower that support the diagrid. Laser scanning was utilized to compare the as-built placements to the 3D model. The detailed 3D modeling also eliminated normal MEP installation issues. MEP frequently stymies a project late in the building phase. We believed it was a major risk, but it hasn't happened. It all fits so well, Bowley remarks. You've already gone through the pain in the digital model, so stick to what you draw. The amount of labor put into the modeling part of things nearly makes it boring. The coordination of NEP engineering began considerably earlier in the project, so difficulties were resolved long before work moved on-site. The museum's facade is about 60 to 70% complete. The small construction crew conceals the intricate engineering required to create each panel. No two fiberglass panels are alike due of the building's shape and calligraphy cutouts. Before the stainless steel finish and glazing, each of the 1,024 panels must be separately molded and fabricated. It's a labor-intensive procedure that just 6 panels may be made every day. Afan, the facade provider, spent a year to develop the panel structure and design, as well as prototype the production processes, including computer-controlled milling machines. Again, digital modeling is vital. These distinctive glazing units join with neighboring panels to generate the free-flowing calligraphy. Parametric scripting was used to establish the final position and size of the lettering to provide the optimal balance of natural light, solar heat gain, air conditioning load, and aesthetics, while also obtaining LEED Platinum points, the highest level certification awarded to green buildings. Because the building design is integrated, modifications to the calligraphy impacted the diagrid and MEP. We were trying to answer 4 or 5 simultaneous equations, Bowley explains. All the elements were constantly integrating and evolving. I can't tell you how happy we were when the first run of panels matched. T. Bowley. The Museum of the Future was designed to achieve LEED Platinum certification. The building will have modern building controls, gray water recycling systems, and regenerative drive elevators. Visitors can charge their electric vehicles while touring the museum, and parking places are limited to encourage public transportation. The museum will ban single-use plastic, and Carlson says cultured meats and alternative proteins may be on the menu. The museum's exhibits will also promote sustainability. Climate change, space exploration, and the future of healthcare and wellness will all be covered in detail. The exhibit will cover how global warming affects important ecosystems and how to heal them. It will examine how solar energy collecting in space and asteroid mining may assist humanity, as well as spirituality. This year's theme is Humanity's Biggest Challenges and Creative Solutions. In the future, we will focus on people, not gadgets. Lath Carlson. Using augmented and virtual reality technologies, the visitor will be transported into the future, creating an immersive theater experience. This is not a museum with things in cases with labels, Carlson explains. Many of the primary galleries will have no labels. It will be a fully immersive experience that involves the visitor as a participant rather than a passive observer. He intends to offer a positive outlook on the future in contrast to the entertainment industry's often pessimistic stance. We want to highlight how people may be creative while yet being realistic, he explains. The futuristic gadgets will be on display on one floor, but the focus will be on technology that will serve humanity, such as helping to feed the planet, provide clean water, or improve transportation. Over 1 million tourists per year are expected, half of whom will be from outside the UAE. The focus will shift inside at the end of the year, but the team understands that the exhibitions must be as impactful as the building that houses them. Still, Bowley hopes the museum will be a model for modern architecture. Due to its unusual shape, everything had to be planned ahead of time, from fire evacuation and smoke extraction to exterior cleaning. The number of lifts, the design of the toilets, and the arrangement of the ticketing hall were all determined using parametric models of people movement throughout the structure. The data from the planning and building phases will also be used to inform museum operations. Bowley believes he learned a lot from this project. The framework is intelligent and integrated, and the solutions are optimized. These are not just about saving the client money, but also about the building's safety, health, and welfare. This project forced us to change everything we knew about constructing. We couldn't have solved the shape-related issues otherwise. I think it's wonderful for the industry. Dubai's Museum of the Future has already become a showpiece for future technology building architecture. Thanks for watching this video. Make sure to give this video a big thumbs up and subscribe to this channel for more.